Dear students, now we are going to learn more about the magnetic field lines, the properties of magnetic field lines. You see, we have just learned that magnetic field lines are imaginary line along which an isolated north pole will tend to move when placed in magnetic field, and if it is able to move. Means, say for example, if we have a bar magnet and the N represents the north pole and S represents the south pole of the magnet, and if a north pole is placed over there, then that will tend to move along the direction as shown by this line, and so therefore this line is called magnetic field lines. It is an imaginary line along which a isolated north pole of a magnet, when placed over there in some magnetic field, will tend to move along that path if free to do so. Means if it is able to do so, it will move along this path. Means if a north pole is having wheels and freedom to move in all directions, then when placed in over there, it will start from this point and finally reach this point after following this very particular path, and that is called magnetic field lines. Now there are few properties of the magnetic field lines which are very important to understand. It always originates from north pole and terminates at south pole. You can very well understand, nothing unusual, because if you place a north pole over there and north pole of the bar magnet will naturally repel it, so it means it should move away from the north pole. So therefore the magnetic field lines originates from north pole, moving away from it, and terminates at south pole. Second is very important, the tangent to the magnetic field lines drawn at any point always shows the direction of magnetic field at that point. Say for example, if we talk about point C, and we draw a tangent on point C on the magnetic field lines at point C, we draw a tangent shown by the red arrow, then the direction of this arrow will be along the direction of magnetic field at point C. Means the direction of magnetic field will be indicated by the tangent drawn at point C on the magnetic field lines. Similarly, if we talk about another point A, we draw a tangent at point A on the magnetic field lines, then the arrow red line shows the direction of magnetic field at point A. You can very well see that the direction of magnetic field at point C is very much different from that at point A, and it is varying everywhere, because the direction of tangent at each point on the magnetic field drawn will be different from each other, because it is returning to the south pole, so it must keep changing gradually. So this is very important to remember, that magnetic field lines, tangent to the magnetic field lines shows the direction of magnetic field. Now third point is magnetic field lines per unit area always proportionally shows the magnitude reflects the magnitude of magnetic field in that particular area or zone for which number of magnetic field lines per unit area is computed. Say for example, in this case, if you see, we have same area selected for three zones, shown by this red rectangular block. Here you see there are three lines enclosed by the same block, and in this case you see there is only one line enclosed by the block, and in this case you see there are two lines enclosed by the block. Just for sake of understanding, I have tried to make you understand and feel that how strength of magnetic field at a particular zone could be estimated. We find the number of lines per unit area for a given zone, and more is the number of lines per unit area, stronger will be the magnetic field over there. So here we have more lines enclosed, that means magnetic field is strongest. Here we have moderate magnetic field lines enclosed by the area, same area, so that means the strength of magnetic field is moderate over there. And in this zone you see only one magnetic field lines is enclosed by the same area selected for all three zones. Here we have only one line passing through this area, that means strength of magnetic field is weakest over there. So that means more is the number of magnetic field lines per unit area, stronger will be the magnetic field at that zone, at that location, at that particular area. And for this, greater is the density of magnetic field, stronger will be the magnetic field at that point. Means it is proportional. So fifth point is magnetic field lines never intersect each other. Here you see clearly no magnetic field are intersecting each other, and there is a very clear-cut reason behind it. Say for example, we assume that the two magnetic field lines are intersecting. Say intersecting at some point L. Now, when you draw a tangent on the first magnetic field line, the tangent will be along this direction. And if you draw the tangent on the second magnetic field line, the tangent will be along this direction. Now there will be a confusion. You have tangent in two different directions. So that means what should be the direction of magnetic field? And that is not true. They should not intersect, because if they intersect, they will give us two directions of the magnetic field at the same point, which is not possible. If there are two magnetic fields applied at same point, we always have a resultant of those two magnetic fields, and that will finally have only one direction. So that means two magnetic field lines never intersect, and if we happen to have two magnetic fields superimposed and in the same zone, then for that case what happens? The resultant of those two magnetic fields will be there, and that will have only one direction. Thank you and have a nice day.